Previous classes we have discussed the measures of association between the attributes. So we have discussed about Yule's coefficient of association and a proportion method. Now we are going to discuss about chi-square test. This is pronounced as chi. We call this as chi-square test. The purpose of this test is nothing but for testing whether the given attributes are independent or not. In addition to the above one, like Yule's coefficient of association, that Yule's coefficient of association is used only when it is a 2 by 2 classification. Means whenever we have other than 2 by 2 like 2 by 3 or R by S classification with respect to attributes, Yule's coefficient of association cannot be used to find out whether the attributes are independent or not. So if you observe this question in page number 318, a cigarette company interested in the effect of sex on the type of cigarettes and cigarette smoked and has collected the following data. Means here if you observe that you have cigarette size and number of people under two categories, male and female. So by looking into the data, okay, we can say that it's a data related to attributes. Smoking, as I said, your attributes are qualitative characteristics. Smoking and effect, all those comes under attributes. Moreover, it is given that test whether the type of cigarette smoked are dependent on sex or not. So you need to find out whether these two attributes, we can consider cigarette size as one and the number of people smoked like male and female, sex of the people as another attribute. So we have two attributes here and we have 1, 2, 3 classifications. So if you observe the data clearly, here it's not a 2 by 2 classification. To test whether these two attributes, the gender and the type of cigarette smoked, are independent or not. Moreover, these two are attributes. To check whether these two are independent or not, as this is not 2 by 2 classification, we cannot use the Yule's coefficient of association. So the other alternative method to test whether these two are independent, these two given attributes are independent or not, is nothing but chi-square test of independence. So here you need to follow 3 steps called null hypothesis. So you need to test whether the two attributes are independent or not. So for that we name this as chi-square, and its formula is nothing but chi-square is double summation Oij minus Eij whole square by Eij. You are going to calculate this chi-square. I will tell you how to calculate, and after calculating this chi-square you need to compare that with some table values will be given to you in the question itself. Chi-square r minus 1, this is called the critical value or table value. You will compare these two. Whenever this chi-square is less than chi-square r minus 1 into s minus 1, we conclude that two attributes are independent. Whenever chi-square is greater than chi-square r minus 1 into s minus 1, we conclude those two are dependent on each other. So to test whether it is the two attributes are dependent or independent, we are going to use the chi-square test. Chi-square, the formula for chi-square is this. To conclude about that, you need to compare with the critical value. Whenever this calculated value, this will be given to you. Whenever this calculated value is less than this table value, we say that the two attributes are independent. Otherwise, we say the attributes are not independent. So let us go to the problem now. So if you observe that you have 1, 2, 3 rows. So number of rows here is indicated with R, and you have 1, 2 columns. Means you have S, we are going to use S is equal to 2. Now clearly it's a 2 by 3 classification. Okay, you have 3 rows and 2 columns. This stands for rows and columns. So it's a 3 by 2 classification. Okay, so to calculate chi-square, we wrote the formula for chi-square as Oij minus Eij whole square by Eij. We have summation here. So let us see how to calculate these values. So it is in the page number 318. Please look into the question while I am discussing. So this tabulate the given values in such a way that here OIs are called observed frequencies. EIJs are called expected frequencies. That is, given frequencies are called OIs, EIs are to be calculated. The formula for EIJ is nothing but AI into BJ by N. So I'll tell you how to calculate this. So you need to formulate this in a table. I said you that given frequencies are called the observed frequencies. So let us write the column OIs given. EIs you need to calculate. Then you need to calculate OIJ minus EIJ whole square. These are the columns you require to calculate chi-square. Again I repeat, you need to calculate chi-square. For that, chi-square formula is OIJ minus EIJ whole square by EIJ. So OIs are given to you. You need to calculate EIJ. Then you calculate the numerator OIJ minus EIJ whole square. Then you divide that with EIJ. Thus, as you have sigma here, the total of the last column is going to be chi-square. So let us, I said you OIs are nothing but given values. So first frequency is 25. Go column wise, 40, 30, 30, 15, 10. All the given frequencies are taken in column wise in OIJ. Now I said you the formula for EIJ is nothing but AI into BJ by N. So to calculate those EIJs, again first one I'll write the table again here, 25. This is the given data for you. Some totals are given to you, 55, 40, 95, 55, total is 150. So you have 25 here. To calculate the corresponding EIJ, okay, this is the position of here. Take the row total. What is the row total here? 25. It is in the first column. What is its total? 95. So to calculate EIJ corresponding to 25, you need to use this formula 55 into 95 by EIJ. First EIJ will be 55 into 95 by, this is capital N, 150, which is nothing but 34.83. Similarly, to calculate with respect to 40, you have 55 here. 55 into 95 by 150. Again the same value, 34.83. If you want to calculate with respect to this 30, okay, you are going column wise. If you want to calculate with respect to this 30, you have 40 here and 95 here. So that is nothing but you will get 40 into 95 by 150, which is nothing but 25.34. And similarly, if you want to calculate with respect to this 30, you need to take the product of these two, 55 into 95 by 150. Okay, so you fill that column in that way, you will get okay. After calculating these EIJs, now you go for OIJ minus EIJ, that is 25 minus 34.8 whole square. Which is nothing but 96.6, and 40 minus 34.83 whole square, which is nothing but 26.7. 30 minus 25.34 whole square, which is nothing but 21.72. 30 minus 20.17 whole square, 96.63. And 15 minus 26.73. 10 minus 14.66 whole square, 21.72. Now this by EIJ means 96.6 by 34.83. You need to divide with corresponding EIJ 2.74 and 26.7 by 34.83 and fill the rest of the values. And the total of this is going to be chi-square, which is nothing but 11.995. So we have calculated chi-square as 11.995. So you need to compare this with table value which will be supplied to you. Here R is number of rows is 3 and number of columns is 2. So chi-square 2 into 1, which is nothing but chi-square 2. This value will be given to you, and chi-square value 2 value is nothing but chi-square 2 value is nothing but is 9.21. Chi-square 2 is nothing but chi-square 2 value is from the tables. I think in majority cases you will be given the table value with you 9.21. Here clearly chi-square value means we got that as 9.995. Clearly greater than chi-square 2. Whenever I said you in the beginning, whenever chi-square calculated value is more than degrees of freedom, we say that two attributes are not independent. Attributes are not independent. Means hence the type of cigarette smoked and the sex are not independent. Okay, thank you.